going on, guys? Let's do this problem right here. So first of all, let's put the question is asking determine the shear force and the moment at point C and D. So first of all, let's put all the forces acting on it. So this can have point B can have two forces, vertical and horizontal. Let's say this By, Bx, and this can only have vertical force. So let's say this Ay. So first of all, to find C, we need one of those information. We can actually eliminate B altogether, but to eliminate that, what we can do is we can take the moment around B, so we can find the Ay. So let's take moment around B and see what we can get. So moment around B equals 0 in statics, and if I take that one, if I take clockwise positive and solve for this one, so clockwise mean 300, this is going to be a positive number, 300 is in 8 feet distance, so it's 300 times 8, and this is acting counterclockwise, so it's going to be minus 500 times 8, and Ay is pushing this object clockwise, so it's going to be positive Ay times 14 equal to 0. So these are the forces acting on it, and if I calculate Ay, it comes out to be 114.3 pounds. So this is my Ay. Now I can calculate this C. So if I take this part separately, so I cut this one here and separate this. So if I take this part here, it's gonna have 500 pounds, and Ay acting upside. Also we have shear force, so we assume the direction. Let's say this is the direction, and we are going to also have a normal force, and that's it. So first of all, let's see what we can find. So if I take horizontal forces, so if I say it's, sigma f of x is equal to 0 and find the values, I will get NC is the only one, so NC is going to be equal to 0. So that's my NC, and to find VC, we can take the horizontal vertical forces, so sigma Fy equal to 0. This is this direction, this is upper direction positive, and if I solve for this one, I get VC plus Ay minus 500 equal to 0. We know Ay already. If I substitute and find the VC, it comes out to be 387.7 pounds. So this is my VC. Since we have this, and now we have to, so they are asking moment and shear force. So VC and moment are the question. So let's find the moment at C. So if I take the moment at C and take the clockwise positive, I will get MC. First of all, we are going to have MC. Let's say that is acting clockwise. So MC, then we have 500 pushing this object counterclockwise, and this distance is 4 feet. So I'm gonna have minus 4 times 500. Then Ay is pushing this object clockwise, it's in 10 feet, so it's gonna be 10 times plus 10 times Ay. We know the Ay already, and equal to 0. So from this one I can calculate the MC. It comes out to be 857 feet pounds. So that's my answer. 4 pounds. And now we are done with the C. Now we have to find the D. So in order to do that, I separate this part. and calculate. So if I separate, I will get VD. So let's say it's acting upside, and also I'm gonna get FD by ND, normal force, right? Normal ND, let's say ND. And also we have to calculate the moment. So if I take counterclockwise direction, let's see what happens. And we also know there's a 300 pounds acting on this, 300 pounds, and its distance is given 2 feet. So if I take the horizontal forces equal to 0, and it comes out to be ND is the only horizontal forces, so therefore it's going to be equal to 0. And to calculate VD, I can take the vertical, Fi is equal to 0, and if I calculate that one, I will get VD minus 300 is equal to 0. So VD is going to be equal to 300 pounds. So this is my VD. Now I have to calculate the moment. So if I want to calculate moment, let's see, moment around D equal to 0. If I take counterclockwise positive, this is going to be positive number and positive MD, and we have 300 pounds pushing this object counterclockwise, so it's going to be negative 300 times 2, and that's it, equal to 0. So it comes out to be MD is equal to 600 pounds counterclockwise. So this is positive, therefore it's automatically counterclockwise, and that's all we have to find. So the question is moment at point C and D. So we have found everything. I hope you guys like this video. See you next time.